So the thing we ask ourselves is, where does tau max occur? Okay, where does tau max occur? Right. So I'm going to. This is not so obvious. Okay. It's only obvious if we have a non-hollow. Right. As you can see, if it's non-hollow, right? At this point, tau max will occur at the centroid. Now, some of you might say, Eugene, why is that? Okay, because if we were to follow the transformation where this is y and z over here, this is rotation about x, right? So if we were to calculate the first moment of area about the z-axis as the function of y, right? So so our variable over here is y, okay? The maximum point, the distance from here to here, this is c, right? And we know that, okay, so this over here, I call my width, right? So it's equal to width depth y bar, right? And this, which we have derived, is because y, right? Then you have c minus y, and then you have c plus y, and then you have multiplied by half, right? So for this case, qz, when qz is at its maximum, it occurs when qz is the y is equal to what? Y is equal to 0 at the centroid, right? So this you will have, when it's 0, you have omega c squared over 2. Okay. Now, for this case, right, this is valid because the thickness is constant. Okay. So if you look at our diagram over here, right, I will now divide this into 3 parts. Okay. So I'm going to divide this into one part. Okay. So I call this the upper flange. I'm now going to call this part our web, and I'm going to call this our central flange. Okay. So this is where the analysis comes in. Okay. So now if we were to divide them, because we don't know, okay, we don't know where the first thing we're going to admit now is we don't know which region has the what? Highest Q over T ratio. We don't know. Okay, we don't know. Right? You cannot guess. Right? You cannot guess. So now we have divided them into section, right? So section. But by observation, we do know something. Okay, so if you look at the section, so we have the upper flange. Okay, now remember, we cannot assume. Okay, in the term test, if you assume wrong, marks will be deducted. If you assume right, you have no mark. So in engineering, okay, there's always a possibility to be sure of the answer, and you cannot make the assumption. You cannot say, I'm going to assume that the centroid has a no. You cannot make big assumption like this. Okay, that's where problem will come later on. So we have a section, and then we have our web, and then we have our center flange. Okay, and then I'm going to pick points. Okay, so the point I'm going to pick at this point over here, okay, this is my point A. Over here is my point B, and over there is my point C. Why I pick those points? Because I'm going to maximize my first moment of area relative to the thickness. Okay, and you can see when I pick point A and point B, I don't pick somewhere in between point A and point B, because at a constant thickness, right, at the web region, the maximum first moment of area is at point B. Okay, so no point. So do not pick a point here called J. Okay, you're wasting your time. Okay, you're not maximizing your first moment of area based on a constant thickness. Okay. So now coming back to here. So based on points, we are going to look at point A, point B, and then we have point C. So the next thing that we highlight or we look at is you look at the thickness, right? So at the upper flange, the thickness is equal to 50 millimeters, 10 plus 30 plus 10. Okay, so 50 millimeters. On the web, right, you only have what? 20 millimeters. And then on the center flange, again, we are back to 50 millimeters. Now, if we now consider the first moment of area, right, we know that the upper flange at point A, right? So now if we look at point A, we know that the Q of the flange or upper flange, okay, Q of the upper flange, right? And we know at point A, Q will be its minimum. Okay, we are very sure about that. Now, at point B now, right? At point B, we have to consider the first moment of area. We have to consider the Q of the upper flange plus Q of the web. Okay. And on the last one, we have to consider the Q of the upper flange plus by the Q of the web plus by the Q of the center flange. So we know over here, this will be our Q max. Okay. Now, if we look at the thickness, right, we know that at the upper flange, this is our T max. This is our T max. And this is our T min. Okay. So you have our Q min. So at point A is we have our Q min divided by what? T max. So when that's the case, the Q over T ratio is very what? It's very low, right? Okay. Whereas for the next case, you have the Q of the upper flange, the Q of the upper flange, plus by the Q of the web. But however, you divide by what? T min. Now, we don't know whether is this the T Q or T max. We don't know. I don't know. I have absolutely not a clue. Why this is a contender? Because the denominator is at its minimum. You can see that now, right? Whereas the next one, right? You have at the center flange region, you have Q max, and then you have what? T max. Now, is this the Q over T maximum? We don't know. So the only way to know about this is you have to what? Calculate. For very sure, we know that the upper flange is never a contender. Right? We know that. Why? Because the first moment of area is the minimum, and unfortunately, the thickness is at its what? Maximum. Okay, so don't bother. The web and the center flange are the one that we have to take into consideration. The web having the minimum thickness, the center flange having the maximum first moment of area. So remember, I told you, right? The Q over T, the magnitude are always fighting against one another to see which can take the largest shear stress. Okay, so that's where I like to say this. This is where things get interesting. Okay, so when that's the case, let's calculate. Okay, so again, for now, do not worry about the V over I yet. Right? Why do not worry about V over I? Right? Regardless of whether is it point A, point B, or point C, V over I ratio are all what? Constant. That's why I teach you all this concept. The shear force and the second moment of area is always constant. Okay. Now, when later on, when I post the homework, okay, the homework somehow they do a different approach, but apply how I teach you. It's so much easier to understand. Okay. So always remember the V over I ratio is always a what? It's always a constant, regardless of where or which section you are looking at. Okay, so now let's start formulating the V over I ratio. Okay, sorry, the Q over T ratio, not V over I. Okay, so now I'm going to be very specific over here. So as I said over here, this is our point A. Over here, this is our point B. And by observation, right, we know that this is our centroid. And at this point, this is our point C. Okay, so with reference to our transformation, right? So I'm going to calculate the Q, okay, the Q at the Q about the z-axis for point A, right? So with depth y bar, okay. So we are at point A, the width is equal to 0.05. The depth is 0.01. The y bar, so we know that this is 20, this is 30, and this is 10 divided by 2, right? So it's 20 plus by 30 plus by 10 divided by 2.